Okay, so in this session, we are going to talk about how you access images and display them. You've seen examples of it in a few of the sessions that we've had already, but we're going to go into a little more detail about how to do this. And of course, as with all of the sessions that we're presenting this week, the slides are posted on links to the slides are posted on the Data Academy website. So if you need to refer to them, especially many of them have links embedded in them, those are available to you. Okay, so today this is going to be hands-on if you'd like to follow along. Tutorial, as with many of the sessions, it might go pretty fast. So keep in mind that we are posting recordings of these sessions to the Data Academy website, so you can go through them in more detail later if you need. But we will go through quickly how to access images from the Butler and from the SIA service, simple image access, and how to, hopefully we have time to show you how to retrieve image cutouts, and we'll show you how to display images with Firefly and how to manipulate them, work with the images with the Firefly viewer. I wanted to note that there are many more tutorials about image access, including things like, how to make very large cutout coads, how to make RGB color composite images, how to display images with Matplotlib inline in your notebooks, for example, and various other things. So do check out the other tutorials, and they're also great. All of the ones that you'll see today are present on the web page in rendered form. So if you forget the incantation, for example, to query the SIA service, you can always use those as a reference. Just a quick reminder, you may have seen this already, but just a reminder that the community forum is a place, sort of our help desk, where you can go and ask questions, how you can discuss things, you can use it as a resource to search. Perhaps somebody else has had the same issue you're having, and you can search and find the solution. But also note that if you post in the support category, we do our best to ensure that everything posted in the support category gets a response. So do use this as a resource. And very quickly, we've seen this already, but in case this is the first session you've been able to attend, just wanted to note that all scientists and students working at or enrolled at institutions in the US or Chile are data rights holders, meaning they can access the proprietary data products from Rubin. Beyond that, there is a list of specific named members of the International In-Kind contributing teams. And that list is linked here. And so in order to access the proprietary data products, so things that we make available to the data rights community for 2 years after that data release, that is the proprietary period. You need to be a data rights holder. After that, the data will all go public after 2 years. Okay, so image access. We have many services, as you've seen. You may be wondering, when should I use each of the services? What are they best for? So the Butler, which you just saw some demo from Andres, is recommended when you're in the notebook aspect. That is the best way to access images from your notebook. When you do it, if you want the full image, that also is the best way to do it, is from the Butler. But you can also make cutouts either by retrieving the full image and making a cutout afterward, or if you see this notebook, 104.5, it shows you how to actually just retrieve a piece of the image directly from the Butler as well. So do check that out. Um, if you are familiar with SIA, Simple Image Access, uh, that is a great way to sort of remotely access images. You can use it from within the notebook and the portal. You've seen a demo of the portal perhaps yesterday. Um, but it's maybe not as intuitive. So we sort of recommend only use this if these services are already familiar to you, or if you have a specific reason, like if you want to use the cutout service, then the SIA or TAP will give you the access URL that you need to pass to the cutout service to make cutout images. And so the cutout service, we have demonstrations of the cutout service. Basically, it will only transfer the cutout portion of the image, so it's more efficient. You're not grabbing the whole image and cutting it after. So if you need many cutouts, for example, you want to use the cutout service directly. And you've seen examples perhaps of Firefly in use. That's our interactive image display tool. And it knows how to handle all of the different planes of the images that our pipelines produce. So it knows how to do things like display the mask planes and other things like that. So we'll go through some demonstrations of various of these. Before I dive in, um, and while I open up the science platform, uh, if anyone has questions, please either pop them in the chat or feel free to unmute and ask your question. But for now, we're going to go to the notebook aspect at data.lsst.cloud. And I really hope you all can't hear all of the sledgehammering that's happening outside my my place right now. They chose today to do a bunch of construction work on the stairs outside. Okay, so we're going to open the notebook aspect. It's going to ask me to log in with my Orchid ID. Oh, good, it remembered me. Accept the defaults. So the first demo here is going to look very familiar. It's very similar to one of the ones that Andres just showed you, with a slightly different goal in mind. Okay, we don't need the welcome. So the first one we're going to open is, notice that we have, excuse me, in the DP1 tutorials, we have in the 100 level how to use RSP tools, we have an entire section on image access and display. So you can see there are 9 tutorials here for you to go through at your leisure. Right now, we're going to start at number 1, Butler image access. Okay, so this is just going to show you, you just heard about the Butler if you attended the previous session. So I won't talk much about what the Butler actually is or what it does, but this is just going to show you how to do some basic query to retrieve images and then how to display them. And then we'll get into some more detail afterwards. So you import the Butler from the LSST science pipelines, as well as our display tool, AFW display. And then here you're going to set the display, this AFW display, you set that display to send images to Firefly. So when I do this, it will open the Firefly image viewer. I'm going to rearrange it so that the images appear next to my notebook. Let's make it a little smaller so you're able to see things in the notebook. Okay. So now we just instantiate the Butler with the standard incantation, sorry, for DP1 and the default collection that contains all of the data preview 1 data. All right, so this is basically reiterating some of the things that were in the last session about the Butler. So we'll just go very quickly. There are 5 different types of images that are available to you. There are the deep coads, which is where you've taken many visits and stacked them together to make a deeper image. There are the template coads, which are the 1/3 of those visit images that had the best seeing stacked together. And those are used as templates for difference imaging. The visit images are the single visit data that are calibrated, and they are per detector. Then there are difference images, which are the result of subtracting the template image from each visit. And of course, you do have access to the raw data, which you will hopefully not have many uses for because you're probably going to want calibrated data. Okay, so we will show you an example of retrieving deep coed images by defining a coordinate in right ascension and declination and the band that you want to retrieve. So we'll do an R band here. You're welcome to modify this as you wish. And then we just create a query string and we'll print it to the screen that just says we want the band to equal R. We want the region to overlap this RA and DEC point. And so this is what the query is going to look like. You just pass this string directly to that Butler query data sets. So this is doing a query of the DP1 Butler for all deep coads that meet this constraint, overlapping this point and taken in the R band. So we'll try that. We could actually see how many that brought us. Let's try this. Okay, so you can see there are 2 images that it returned that meet that criterion. So if we want to retrieve one, we can now take the first of those data set refs. So we just index it with a 0 and we say butler.get. And it knows how to deal with that data set reference. And it will retrieve that deep coed image. And then to display it, we use the AFW display and this method called MTV that displays the image to the Firefly viewer that's open in the adjacent window. And there you have a beautiful coad image. We'll talk more about the Firefly display in just a few minutes. So then we just delete the files that we don't need anymore. To retrieve visit images, of course, these are the single visits. So you can actually put constraints on this where you say, I want only things that were taken between this time and this time. So we'll show you how to do that here, where you define a time span that is 1 night from the early DP1 observing. And so to do that, we define these time objects. You also saw an example of this in the Butler tutorial. We define the initial time to be this date. And then we define the second time to be in MJD. So these are just 2 different ways to define times. But in the end, actually, and we'll just see what it looks like if we print. But then you can see in the end, once you've created these time objects, this time span, which is a Butler method, converts them to the same format. And so now you can pass that. You can say in that query data sets, you can say I want visit images where the band name equals that R band that we defined earlier, and it overlaps RA and DEC. But then we can also say where the time span overlaps this time span that we defined above. And so this will return a list. Let's find out how many it returned. That returned 18 visits that met our criteria. So as we did before, you can just, from those data set refs, you can retrieve the first one by indexing it with 0. We can retrieve the 10th one by giving it, or 11th one, I guess it is, by giving it a different index. We'll do that. And then we'll display it again to our Firefly image display, and you see our image is available here. So that's the very basics about how you retrieve an image from the Butler. And that is, as I said, that is the recommended way to do things when you're working in the notebook aspect. So next, I wanted to show you more detail about how to use the Firefly display tool. So we're going to open, sorry, I should tell you what I'm opening here. This is again in the 100 level, how to use RSP tools, image access and display, and it's 103.5, image display with Firefly. So this is a notebook tutorial. You may have seen a version of a portal tutorial doing the same actions in yesterday's sessions, because Firefly is also used as the image display tool in the portal. And so this is just some basics about how to use Firefly. Again, if we go back here, there are other, there are other Firefly tutorials in the portal section, for example. There are many portal tutorials that you can check out as well. But we're going to do this brief notebook where, again, we do the same as we did last tutorial. We import the Butler and we import this AFW display. And then we instantiate the Butler pointing to the data preview 1 repository and collection. And again, we set the default plotting backend to Firefly. It's already open, so it didn't need to open a new window. And we do already have our side-by-side view set up. So this is great. And just as we did before, this is the exact same query. I think we define our RA and DEC coordinate and the R band, and we say query data sets that overlap that position, and then get the first one. Oops, did I not execute? I didn't. There we go. Okay, and then as we did before as well, we're going to say AFW display dot image, and we're going to pass it that deep coad image. But you'll see it looks kind of wacky. Don't worry, nothing is wrong. The reason it looks that way is because this is showing you all of the mask bits that are set for this image. And we'll talk more about what that means. So by default, it's going to show you the mask on top of the image. Now you can make that go away from the notebook here by saying AFW display set mask transparency 100, meaning 100% transparent. And now that mask has gone away. You could set it to 50% transparent, and then you'll see the mask is back. Now, if you want to know what all of these different colors and shapes mean, you can get the mask from that deep coad object that you have. You'll learn much more about the different image types in sessions that we have tomorrow. But basically, these images, these are very rich objects. This is not just the image itself. It contains, the mask. It contains information about the point spread function and all kinds of things. And so you can actually retrieve that mask information. And then that is you can retrieve it as a dictionary, and then just loop over the items in that dictionary and say what what color corresponds to each mask. And so what that shows you is that bad pixels should be colored red. The one that you see here that's this green color is, oh my goodness, there we are. Okay, detected is blue, actually. So anything that was part of a detected source will be colored blue. You can barely see that poking through some of this. The green is the edge of a detector. Remember, this is a coad, so it's a bunch of things at different orientations added together. So you see all the detector edges as those lines, those green lines. You can also see this information. You don't have to do it from this mask plane dictionary. You can do it actually in the Firefly display. So this thing that looks like a stack of this is the image planes, the overlays. So you can if I mouse over it, it'll show me the tooltip that tells me what each of these tools is. But we want this tool that looks like these mask overlays. And if I click that, it opens a list that now shows me the colors corresponding to each of the mask planes. Um, we'll come back to that in just a second. Let's set them all to transparent again. And then, so this shows you how to set the transparency for just the detected plane to 80%. So if you want to look at just one of the mask planes, for example, this is showing you these are all the pixels that are part of detected sources in this image. Then we can redisplay all of the masks again. But we can also do a similar action by again going to this box, and you can just deselect the ones that you don't want. So I can remove all of them except for the detected, um, and get something like that. You can also change the mask color. So say I don't like that blue, I can click on this color here, and I can change it to, I don't know, let's say I want this nice cyan looking color. And then click OK. There we go. You can also change the colors from your notebook. So again, I already changed it. Let's change this one to deep pink. We just used the actual hex code for this deep pink color, and redisplay the image, and it shows you that detected mask plane in that color. I already showed you how to change it from within Firefly, so we'll move on past that. Okay, so you can do many more things. Let's just make this a little bigger. You can manipulate the display quite a bit in here. So this uh, image stretch tool looks like a histogram here. If you click that, it pulls up all kinds of options. You see by default, it was showing me a linear stretch um, with pixel values from 0 to 99. Let's say instead we want to select Z-scale um, hyperbolic arc sine ascent stretch. So you can see the image stretch changing. I can do Z-scale log stretch, for example. So this is useful for many purposes, to set the image display explicitly. You can also do the same from the notebook. So now here I can say scale it again ascent from uh, the minimum to maximum values, -5 to 100. It rescales it for me. You can use an automatic algorithm like the Z-scale algorithm to determine those thresholds automatically for you. Um, this is great. And then let's go ahead and just set it back from the command line. We can set it back to the default, which is linear from 1 to 99 percentile, I think. Okay, so you can also zoom in and out on the image from by sending AFW display.zoom levels from your notebook. And so there we set it to zoom 4. So we zoomed in by a factor of 4. We can zoom back out or zoom to factor 1. But you can also then, within the Firefly window, you can just use your mouse to zoom in and out. You can also pan by clicking your mouse and moving around. So if we go and let's go and we can hide all of the masked planes, and then we can just go and look at our nice image. Um, and then finally, again, this is just scratching the surface of the things you can do here. But one of the last things I want to show you is how do you overplot the objects from your catalog of detections and measurements onto the image. So we can do this using the exact same data ID. This is one of the nice things about using the Butler. Remember, we retrieved those data set references, and they give us information, as Andres told you in the last session, about the tract and the tract and the patch, for example, in the band. That's all stored in the data ID. So you can actually use this to get the exact same data ID that was used to retrieve that image, and then use that to Butler.get the object table. That's object is the detections and measurements from the COAD image. And we tell it, give me the tract from that data ID that I just retrieved, and just give me these columns, the XY coordinates, object ID, and patch. And so we'll go and retrieve those. So now we have a list of objects, and then we want them only to appear in the patch that we're actually displaying. So we'll just pick only objects that match the patch from the data ID, because object tables are actually covering an entire tract. So we just want the subset. And then what you need to do to display them is you need to use this buffering. And the reason for that is if you don't use the buffering, it will redisplay I think it redisplays the image each time that it displays a source. So if you do it within this buffering and you just loop over the sources, then it will do it all at once. So if I execute this, you can see what it's doing is putting a dot, color being orange, and it's putting it at the XY positions that we retrieved from the object catalog. And so when you do that, you can see it has marked all of the sources, the objects, I should say, in the image. And if you zoom in, and if I change the stretch, you can even see it maybe in more detail. You can see that each of these is circling something that's probably a detection. And you can zoom way out, and you can see that that it has marked everything in the entire patch image. And there's some explanation here for why there's a border around it. It's basically the patches overlap. And so these are in the overlap region on the edge, and so they're assigned to the adjacent patch. So this is very useful if you want to know whether your object of interest was detected and cataloged. Okay, so then, and we can erase those by using this AFW display.erase. You can do things like draw lines on the image. So AFW display.line, and you give it XY coordinates. And you can't see it because I zoomed way in. There we are. I can zoom out. Now you can see it drew a line between these two bright stars. You can draw two more lines and make a triangle. And then of course you can erase those again. Okay, and finally, almost finally, I want to leave time for the others. I wanted to show you that you can open multiple frames at the same time. So if I get now, remember we retrieved references for two images, so I'm going to get the second one of those. So index one here. Um, and then again, that's just using butler.get, and I get it using that dataset reference. And then I set up a new AFW display where I say frame equals 2. That should create a new frame, and then I display to that frame that new image that I just retrieved, and you see it'll plot them side by side. And now I can go to each image and use these various zoom tools at the upper left and zoom it to fit in the frame, and you get something like that. Those are my two images. And if you want to, and then if you want to close one of these, you can just click the X and it will close that particular image. Okay, and finally, I just wanted to show you you can use Firefly in the same way that you would in the portal. You can use the Firefly client to actually send plots to Firefly. You can pass it your table of data. So this uses in the AFW display, it uses the get client, and so that uses the Firefly client. And then you just say use client, that Firefly client. And then you pass that object that you just created. You tell it upload a table, and you pass it that table. And now you see that you've got your table in the Firefly client. And then I can tell it to make a scatter plot, and you give it the XY columns and titles and labels and everything. Notice that it didn't appear immediately. It still is showing the default plot from the table, but if you click this pinned chart, that will show you the plot that you just made, which is just the XY coordinates of all the objects. So you can also use Firefly in that way. But mostly you might want to use it for image display. Okay, so we have just a little time left. I want to show you other ways of grabbing cutout images. Let me see. Any questions? What's the difference between a cutout, an image subset, and a zoom in? This is a very good question. The main difference is going to be sort of all of the metadata or all of the ancillary information that comes along with it. So if I, for example, let's see, this is probably a bad idea to do it on the fly, but we'll do it on the fly. We'll add a cell, and we have that deep coad that we retrieved. You can, for example, access the pixels directly of the pixel values of that image. So I could say, give me the pixel values from, XY 100 to 200, 100 to 200, by just accessing the .image extension of it. Oops, didn't like it. I told you it was a bad idea. Oh, right, it doesn't work because I need I would need to look up the actual X naught, Y naught values for this. So the minimum is, yeah, the minimum value is 14,800, 2,800. So, but anyway, you can see if I just do .image, this shows you the array of the pixel values. But then now you've just extracted an array of pixel values, but the entire object here is what's known as an exposure F. And that means it has, for example, the mask. It has, you can, if I do get, you can do like get the PSF, you can get the WCS, World Coordinate System. You can get other properties of it. Whereas if you just extracted an array from the image, you're losing all of that information. Um, there is also in the one of our cutout service tutorials, it shows you there are three different types of images, depending how much of that extra information that you want. Um, you can retrieve a cutout with all of those planes associated, or you can retrieve one that's just the image plane and doesn't have like the variance and the mask and all of that. So that's more lightweight. So if you're retrieving thousands, say, you might want the more lightweight version. So do check out that tutorial if you want to know more about that detail. But thanks for the question. Um, okay. Now, quickly, I'll show you one other way of retrieving images. This is tutorial, again, in the 100 level, 103 image access and display. Let's look very quickly at the simple image access. And then hopefully I'm going to go through this kind of quickly and then I can just show you the cutout exposures very briefly. Partly because it uses the SIA, the simple image access. So SIA is a service to access image data. It's an IVOA virtual observatory standard protocol. So it is useful for finding and in fact for working for manipulating images behind the scenes. So what we do here is we import from the RSP services, we import this get SIA v2 service method. And then we define an RA and DEC. Again, we're going to display to Firefly. And then just like we've done, you've seen with the tap service, we instantiate the SIA service by just saying get SIA v2 service and point it to the DP1 endpoint. And so now we've instantiated the service, and then very quickly we'll show you ways to query that service. So we're gonna set the maximum number of records it returns to 3 just for convenience here. And then we're going to pass it. The first one we're going to do is a circle. So you define the circle by RA dec and a radius. And the radius is in degrees. So we give it that RA and dec that we defined, and we just say 0.05 degrees, and it should give you a list of results. It warns you because we told it to truncate the result set. So that's all that warning is. And then you can print that to a table, and you see it gave us 3 results. They are image. In this case, we got raw images. And you can see if I scroll over here, the important thing that you're retrieving when you do this from the SIA service is this access URL. And this is what you need to actually retrieve the image itself. So we're going to reuse that circle thing below. You can also, I'll note here that you can pass an AstroPi sky coordinate object to do the same thing. And I forgot to note, you can also do things like an RA dec ranges. You can define a polygon as well. It doesn't have to be a circle. Okay, and then you want to specify the image type. So you might want a visit image. So then there's something called the calibration level. So calibration level 2 contains the visit images. Calibration level 3 contains different types of images. So then you need to specify both the calibration level and the image type. So let's demonstrate that. We're again going to go to that SIA service and search the position is given by that circle, and we say calibration level 2. That will give us visit images. And that shows us that there are over 1,600 visit images overlapping that position that we gave it. You can also, I'll skip this optional one because we're just going to do the same thing right here where you say calibration level 3, but remember because there are multiple types of images in level 3, you need to specify that you want the deep coad. So again, we just see a service search that circle, give me the deep coads, and now it has found 12 results that overlap. Oops. And you can see what that table looks like again. Um, it looks like the one we had before, but now you can see their deep coads and the access URLs are in here. And if you want to count then how many are in each band, this just loops over those and counts the number in each of the UGRIZY bands. And so there's 2 in each. That's why you get 12. So there are 2 overlapping patches basically, and then 1 image in each of the 6 filters. You can do the same for template coads. It's the exact same search, but with template coad instead of deep coad here. And again, you'll see you get 12. You can do the exact same for difference image, and remember these come from visit images, so you should get the same number, that 1,600 that we did for visit images, and indeed you do. Okay, we're a little short on time, but the one thing to note is that in the SIA v2 service, the band isn't necessarily the letter name of the filter like G band. It actually uses wavelength. And so here we can specify the sort of rough edges of the band passes of our filters. So we have UGRIZY, these are in, looks like these are in meters. So they're 10 to the minus 7, yeah, 300 nanometers. So, for example, you can define a band that spans from the lower edge of the R band to the upper edge of the I band as a wavelength range. So that's what this is doing here. And then if you pass that as a constraint to the SIA search, it will return images. We hope it returns images in both the R and I band and none of the other bands. And indeed, you see it returns 321 I band images and 466 R band and no other bands. You can also just send it one wavelength, and then it will just return everything that overlaps that wavelength. So in this case, we just give it 500 nanometers, and it tells us that there are 414 images overlapping the G band. And then finally, you can also pass it time constraints. This looks just like the time constraint we just used previously. And you can see that you can pass it as a range to the SIA service. So you can say time equals time 1, time 2. And it tells you there are 131 visits in that time range. So this is all great. Now we know how to query the SIA service. You're probably wondering, but then how do I actually get the image? So let's do that. So we have the results. Remember, we're sending that result from the CS service search to this results variable. And so then what you need to do is 3 steps. Again, this is where if you forget this incantation, the rendered tutorials on the DP1 website are really handy for this if you forget exactly the details of this. But basically, okay, you put that URL, that access URL that I showed you before, into a variable, and then you say data link results dot from result URL. That's the method, and you pass it that URL. And the important thing is here, you need to send it or tell it to authorize you to access that image. So you use this get PyVO auth method to pass your credentials. And then you set that object, and then you say, okay, get record dot get that access URL. That has created this image URL, and you're not done yet. Then you need to read the image into an exposure F object. Remember, I showed you before that these images are exposure F objects, which are these rich objects that contain many additional planes and information. So I can, sorry, I'm going to show you this. Sorry to do a long scroll, but we imported at the beginning from lsst.afw image import exposure F. So we imported that method at the beginning so that we could use it here to put that image URL data into a container that is an exposure F. And now that I've got that, Firefly knows how to display that. So I can display that in the Firefly tab. You see it displayed in the image display tab. And I can set the mask to transparent. So there are lots of sort of search criteria that you can apply to that SIA search. Then at the very end, you just need, I guess it's about 4 lines to actually retrieve the image into your active session. Okay, and I see. Oh yes, good. Christina's providing answers there. This is good. So this is going to be just very quick, just to show you that that process that you just saw can then be used. If I open Notebook 103.4, the cutout exposures, that method can be used, and then you just basically tell the service to do the cutout before it retrieves the image. So that makes things more efficient here. So again, this is just the same thing we just went through, querying for images with the SIA service. And then generating an image cutout. Again, this is the same thing we just saw where you retrieve using that access URL. You retrieve the image, but now we do one extra step where we have this, it's called the SODA service. And you do a SODA query and you pass it that data link result. And again, you have to pass your authorization credentials. We're going to pass that. And now we've set up this SODA query object. And then here you can actually apply a circle. So again, you give it an RA and dec and a radius. You create this SODA query.circle object. And then you tell it, okay, now read the actual bytes from the SODA service, from the SIA service, I guess. And then again, we do something just like we did before. It takes a couple of extra steps to turn those bytes into an exposure F image, but just to show you that it can be done. And this time I'll just display it in the notebook using matplotlib. This shows you that you've got an image of about 300 pixels on the side. And I know we're at time now, so I'm going to stop there. But you can check this out for more details about how to create cutout images to explore this in more detail. Thanks. Let me know if you have any questions. Yeah, Mauricio.
Uh, I'll speak for this because it's easier. I was wondering if I'm trying to get cutouts of sources in a single visit, if there is a way uh, to know in which visits the source falls, or at least if there is a tutorial that shows that, because I can think of some way to test that, but I was wondering if there is a fast way so that when I produce the stamp, I'm sure that I'm producing from a visit in which I have my source.
Yeah, this is a very good question. There are multiple ways you could do this, and I guess my colleagues can step in if they have better ideas than I do. But actually, like one thing, that we did in all of these, for example, you could da, 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 da. We said in the Butler tutorial, we said only give me the images that overlap that RA deck point. So you already know that once you've done that query data sets, you've only got the images that overlap the point that you care about. Likewise, when we did these SIA searches, we gave it, where did we go? We gave it spatial queries, for example. So we said, in this case, I want a circle of this radius. You could give it a really small radius to say, just give me the ones that overlap this point, um, for example. So there are ways of doing that. You could also look up in advance um, the, I think at the very end of Andres's Butler tutorial, he showed a very basic way of using methods from the Butler to actually look up, for example, for coads, which tract and patch overlaps your RA deck coordinate. So you can look up a list of those, and then you could just directly retrieve the images using the tract and patch IDs. So there are various ways to do it. I think we try and demonstrate all of them, but it sort of depends on your usage, I guess, which one you need. But typically, the RA and deck constraints are the simplest. Yes, I see another question from Tuba.
Hello, can you hear me?
Yes.
Okay, so I'm pretty new to this, so I probably will be using the wrong terms, but if I'm using the Butler and I'm trying to get cutouts of visit images, do I have to use SIA service in conjunction with that, or do I have to get like image subset? I know you mentioned explain some of it, but I'm still a little confused. So, can you not get cutouts, like use the cutout service with the Butler? Is that a thing for SIA? So I hope it makes sense.
No, yeah, it totally makes sense. It is a little confusing because there are various ways to to do things. Um, you can retrieve things directly from the butler. Um, and in fact, here I'll pull it, or I'll just show you. I'll just show you here. I'll show you the rendered version. But if you just need a little subset image. There's this image subsets with the Butler tutorial that shows you how to basically pass a bounding box um, that will, let me show you. Where are we? That will just extract the image that you need. So you can do it that way. You can also use the cutout service, the SIA service. Um, that might be more useful if you want to extract many, many cutouts. If you just want one image to put in your paper draft, maybe you might just want to grab it from the Butler, but you can do either, I guess, is the point. And you might just want to explore and experiment to know which one is more convenient for your purposes. But you can extract a cutout from any of the types of images. So from visit images, templates, difference images, cutouts, etc. Or sorry, coads, etc.
Thank you.
Sure thing. Okay, I think we have reached the end of our time. Thank you all for being here. And we have a session, same three presentations we did this morning, happening this evening, Pacific time. And then we have three more sessions tomorrow talking about different types of data sets.